Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3026, maximum good subarray sum. So the question itself is not too difficult, but it requires a bit of observation and optimization. So basically you're given an integer array nums and you want to basically find every subarray. So every subarray, and to see if the first and the last element when subtracted and taken the absolute difference of is equal to k. And if that is the case, for example, 1 minus 2, absolute difference is 1, take the sum of the subarray, return the largest subarray sum. So let's go ahead and do that first using a naive approach. So getting every subarray. So if the absolute difference of nums of I minus nums of j is equal to k, then let's get the subarray sum. And instead of calculating the sum of every subarray, let's use prefix sums. So basically, if you know what a prefix sum is, this is 9, so it's just going to be prefix of this minus prefix of this. So we're just going to say if I is less than or equal to 0, then the prefix sum is p of nums of j. Otherwise, prefix sum is p of nums of j minus p of nums of I minus 1, because we're including up to the current point. So again, prefix of this minus prefix of this. So then we can go ahead and take the maximum and return it at the end. Since we want to maximize something, set to float negative infinity and nums of I minus 1. Oops, like that. Oops. Okay, what's going on here? Prefix sum of nums of I minus 1. Okay. But the idea again is just the max of sum of nums I to j plus 1, whatever the current subarray sum is. So at the end, if this is still float negative infinity, then return 0, as it says right here, if there's not a valid answer. Okay, come on. Okay, so this works, but it's n squared. So let me show you the way I came up with to optimize this. Okay, time limit exceeded. So again, since we're dealing with absolute differences, then why don't we just create a hash map, and basically we're just going to keep track of all the previous indexes visited to the left if we're on this, and then we're just going to basically find the difference. So if for this and we're looking for a difference of k, then we're looking for 3, right? And then let's go through each of 3's indexes. So basically let's have a default dictive type list, and we're just going to say d of nums of I. We're going to append I because we're going to get the value, because we're going to say the difference is, so the value can be bigger or less than k. So we're going to want to do nums of I plus k, because if nums of I is less than k, so if this difference is in our dictionary as a value, then let's iterate over now. And again, low and high is going to be n and then I, because we're only doing this beforehand. So everything to the left, all those indexes are considered. And then if low is less than or equal to 0, then the prefix sum is p of high. Otherwise, prefix sum is p of high minus p of low minus 1. And then we're going to maximize subarray sum like this. So let's call this now is d of diff. It's going to hold all those indices. And then again, because we could also, the current value could also be bigger than k, so we also want to do a nums of I minus k to cover all our bases. So if diff is in d, d diff, same thing, and I if low is less than or equal to 0, because if the left boundary is everything, then it's just the current prefix sum, which is 6. So 1, 3, 6. So prefix sum is p high. Otherwise, p low minus 1. Okay, so again, if, for example, this, then we're going to take prefix of this minus prefix of this to get this subarray sum. So that's a little bit better, but this is still n squared. There could be a lot of indices to the left that we're iterating over, right? If this is a very big array. So let's think about how to optimize this even further. We're dealing with the prefix sums, right? So why don't we just, instead of having to loop through all those indexes again, why don't we just create this logic here instead, right? Instead of appending the indexes, we only care about the subarray sum, because if there's a subarray sum that's already pre-computed from that point, we want to subtract, let's say we're on 6 minus whatever that current subarray sum is, and then we want the biggest value. So we want, for the current value, the value that's the prefix sum to the left that we've seen before, that is the farthest away from the current prefix sum, if that makes sense. So, for example, if the prefix sum at this point is 1 plus 2 plus 3 plus 4 plus 5 plus 6, we're looking for like something that if the value is going to be equal to k, when you subtract or add it to the current number, it's going to give us the biggest subarray sum, right? So there's going to be sorting involved here, and let's use a sorted set instead, because that's going to keep everything in orders, right? So if I is less than or equal to 0, again, then we're just going to add 0, because anything, if like we're looking for this subarray sum, then it's just this prefix sum minus 0, because plus or minus 0 is going to do nothing, right? Otherwise, it's d of nums of I dot add p of nums of I minus 1, right? So that's kind of the idea here. Again, subarray sum of this is prefix this minus prefix up to this point. Cool. So now, now that makes our life a little bit easier, because what we can do is we can go ahead and let's go ahead and print I now and p of I, because this is the current prefix sum up to the current point, right? If we're here, that's 6. If we're here, that's 10, as we're looping from left to right. And let's do that here again. So if diff and d print now p of I. So again, you can see here that so we're trying to do plus I and also minus I. So what that means is we should see 11 here, which we're not seeing. So I might have made a mistake. If it's less than or equal to 0, then we're going to add that. So p of I, and now we're going to try to find the difference between any two values that is the biggest, because we want the maximum good subarray sum. So let's see here. So we're going to append d of nums of I. Oh, we're going to add p of I minus 1, not nums, right? Because we're looking for the prefix sum, right? Okay, there we go. See, now 21 minus 10 is going to be 11, because we're looking for example, if we're less than or equal to 0, then the prefix sum is just 0. If we're here, we're not looking for 2, we're looking for 6, which is 1 plus 2 plus 3, right? And the reason we're doing that is if we're here, we're actually going to append this, because let's say we want the sum of this, then we're going to do this minus this, right? So if we're on this, we want to actually add the previous prefix sum, right? Okay, cool. So now we're trying to find the biggest difference, right? So let's just say, well, the biggest difference is either going to be the smallest or the largest, which is the left or the right, because this is already an ordered set, right? As we're placing this is in sorted order. So let's just go ahead and do low and high is now 0, p of I, and then we're going to try to find the difference between high minus low. and that takes care of part of it. And then we need to do the same thing here. So low high is now 0, p of I. So the smallest value, the leftmost value in a sorted list in sorted set is going to be the max of high minus low. So hopefully that's going to give us our answer, because if the answer is bigger, it's either going to be the one to the very right or the one to the very left. In this case, let's also make low high is now of -1 and p of I, which we probably don't need, but let's just try that. And let's do that here again. We want to find the number that is the farthest away, because if we subtract the number that's the farthest away, we get the biggest difference, which is the subarray sum, right? High minus low. Okay, let's submit this. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video. Thank you for watching.